This video is for Module 2. As you can see, I've already started the module. I've already answered a few questions. The questions at the beginning where you're asked to compute the mean and find the interquartile range for a small number of measurements will not be included in this video. The instructions for those are clear enough. So I've decided to find a more difficult question. Okay, so in this case, you're given a sample. Well, this is actually a subsample of a larger sample of data. You're only shown 100 of these measurements. The first question you're asked is to specify the measurement precision of the data. The measurement precision is 3. There are 3 digits to the right of the decimal. Okay, how many peaks or modes are in this distribution? You can tell very clearly that there's only one. Okay, now you're given some more specific information about the distribution. There are over 2,000 measurements and so on. Specify the most appropriate measure of central tendency for this type of distribution. This is a sort of a flat distribution aside from the mode. The best measure of central tendency for this type of distribution is the mode. Okay, specify the most appropriate measure of variability for this distribution. In this case, there is really no appropriate measure of variability, okay, because the distribution is relatively flat again aside from the mode, but you wouldn't really get a good idea of what the variability is based on the interquartile range or the standard deviation. Okay, so the program now has constructed a frequency histogram. And the first question is to specify the mode of this distribution. The way I do it is I simply say, well, where is the mode located in terms of this table? And it is located between these two category boundaries. Okay, that's where it is. So what I'm going to do is count and say, okay, this is the first, second, third, fourth, fifth, sixth, seventh. The mode is between the 7th and 8th category boundaries, okay? So 1, 2, 3, 4, 5, 6, 7, okay? And the 8th one is right in between. To get the mode, you simply compute the midpoint between these 2 points. So add the 2 points and divide by 2, or simply take their average. So 168.6255 plus 196.7255 and divide that by 2, and it says round to measurement precision, so the answer is 182.676. Okay, now it's okay, so that's the mode. Determine the percentile value of the measure 300.974 to 2 digits to the right of the decimal point. Okay, well, how do I determine that? Well, first let me see if this measurement 300.974 is one of the category boundaries, because if it is, then the percentile value is simply the relative cumulative frequency value that's right next to it. Okay, so 300.974. 300.974 isn't in this column, but you can tell it's between 281.0255 and 309.1255. Okay, so that means that the percentile value that corresponds to 300 point whatever that measurement was lies exactly between 0.8118 and 0.7771. Okay, so the way to figure it out is to use the equations you were given for linear interpolation. Okay, this is the equation that we use. Okay, in this case, we were asked for a percentile value. So if we say all the category boundaries are x values, we're looking for a y value. And this is how we solve for y. Okay, but first you have to identify the upper and lower xy coordinates. So what are the coordinates between which your measurements of interest lie? Okay, so like we said, the measurement of interest, which is 300.974, is between 309.1255 and 281.0255. So 309.1255 is our upper boundary. Now I have to do this on Excel, okay, but you might want to make a table for yourself like this one, okay. So now you know what the upper x value is, you know what the lower x value is, you know what the corresponding upper y value is, as well as the, or sorry, that was the lower y value. This is the upper y value. Okay, now in this case what you are given is an x value. Okay, and what you're doing is you're solving for y. Okay, the way I'm solving for y on Excel is using this exact equation. Okay, but to save time I've programmed it into Excel. Okay, so the y, the percentile value that corresponds to 300.974 is 80.17%. Okay, they want it to be to two decimal places, 2 digits to the right of the decimal, so just to double check, 80.17 seems to be the correct answer. Okay, now find the score corresponding to the 93rd percentile value and specify up to limits of measurement precision. So this time it's not up to 2 digits, it's up to 3. You have to be careful about that. You don't want to lose marks for no reason, or for no good reason anyway. Okay, so in this case, what I'm given is a y coordinate, and I'm solving for x using exactly this equation, which I've now programmed into Excel. Okay, the 93rd percentile, if I look at this table, it's not on the table, but it's between 0.9584 and 0.9212. So 0.9584 is my upper boundary, upper y boundary. Okay, my lower y boundary is 0.9212. Okay, my lower x value is this value here. My upper x value is this value here. Okay, now I've been given my y value, and don't forget, if you're to convert the percentile value into the proper format. Okay, I didn't put in 93.0, I put in 0.93 because this is the way I recorded my y coordinates. If I had converted these into percentages, then I would be able to use a percentage here as well. Okay, so here I'm looking for an x value. It's 400.0728 and so on. So I'm just going to paste that here, but I have to round up to 3 decimal places because that's the format of the data. That was the measurement precision. So I'm going to do that. So I'm going to round up the last 8, and this should be the correct answer. Excellent. Okay, in this case, you're given another sample. You have to specify the measurement precision. How many peaks? This is a single peak distribution. Describe the skewness. In what direction are the data pulled? They're pulled towards the positive direction, so it is positively skewed. Just copy and paste the word you see here. Okay. Positive, you don't make a spelling mistake. Specify the most appropriate measure of central tendency. This should be easy, right? Median. Okay. The most appropriate measure of variability, again, because of the skew, it's the interquartile range. If there was no skew, it would be the standard deviation. You are correct. And then you have to compute the median. It's the 50th percentile point. So again, you have to use linear interpolation. You're looking for an x value. Your y is equal to 0.5, and so on and so forth. You just follow the same steps that I showed you before using these equations. Okay, it's not too difficult. Well, at least it's not impossible.